So let us start our today's session. So in the previous class, we have discussed about the Kachi sequence. So here in this today's session, I am going to take the problems on Kachi sequence, sub problems which hold the Kachi sequence criteria, and some problems which are not Kachi sequence. So then I conclude my discussion on sequences chapter. Then I move to the other concept, which is infinite series. So in this, I will give the basic definitions and the useful results. And then we will do some problems based on the results. That is my view for the today's session. Okay. So before going to start, please ask your doubt with regard to the Kachi sequence, the definition or anything you have, where you have a confusion with regard to the Kachi sequence. So first you ask your queries, whoever have the doubt. If everyone is clear with the definition, then I will take the problem. So let me take the point one more time of Kachi sequence. So if you want to prove that a sequence is convergent, there are different methods available, apart from which if you are able to prove that the sequence is a Kachi sequence, then it becomes convergent, and it is if and only if case. So there is no need to evaluate the limit here. You are just proving that the sequence is a Kachi sequence, and the definition is given by modulus of an minus am is less than epsilon for all n greater than m, or if you use the symbol s, we write like this: Sn minus Sm less than epsilon for all n greater than m, or Sp minus Sq less than epsilon for all p comma q greater than or equal to m. If not, you can write that modulus of Sn plus p minus Sn is less than epsilon for all p greater than 0. This we usually use the definition. Okay. In a simple nutshell, we need to understand that if I have taken epsilon value as something, say 1, 1 by 2, 1 by 4, 1 by 3, whatever the case you take, you are simply specifying the term number m such that in the sequence Sn, what I have considered, from this term number m onwards, all the values in the sequence are becoming equal. However, if there is a gap exists in the values of the sequence, then the difference is at most epsilon. That was the whole idea. It means that for each epsilon, you are specifying a term number such that from which part onwards the values in the sequence are becoming equal. Okay? Is that clear? The another thing is, if you are proving that it is not a Kachi sequence, it means that you can identify a term number for a given epsilon such that Sn minus Sm is greater than epsilon. So violating the condition means this, accepting the condition means this. Okay. So I think it clarifies the doubt over the concept. I hope so. Anybody has any more doubts apart from this? Yes or no? Right. So let us take the problem on it. So you take the sequence Sn defined by n by n plus 1. This is my sequence. Now, if you write Sn, what is the value? N by n plus 1. If you write Sm, the value is m by m plus 1. So, I am taking that n is greater than m. Here, m stands for term number. N is a term number which is bigger than m. It means that if this is the sequence, this is m, I am taking n here. Okay. Now you calculate mod Sn minus Sm. So this is equivalent to n by n plus 1 minus m by m plus 1. Please understand that I am specifying the term number for a given epsilon. You need to understand like that. So here you can simplify this as, this part can be written as 1 minus 1 by n plus 1. So that, and this will be written as accepted. Yeah. So then what happens? The modulus will become as so as you know, n is greater than m. So n plus 1 is greater than m plus 1. So 1 by n plus 1 is less than 1 by m plus 1. So if you consider the modulus, the value in the modulus is positive because you are subtracting a small number from the big number. So this is equivalent to 1 by m plus 1 minus 1 by n plus 1. And obviously I can say that this is less than 1 by m plus 1 because you are taking something out of this one. Again you can say that this is less than 1 by m. Accepted? So at this position I choose the epsilon. So choose epsilon such that 1 by m is less than epsilon. So what happens? Mod Sn minus Sm is less than 1 by m. This you know, and we have chosen epsilon like this. So Sn minus Sm is less than epsilon holds. Now the thing is, what is the term number if that thing holds? So you take this part here. So 1 by m is less than epsilon implies m is greater than 1 by epsilon. So the choice of m is dependent on epsilon, which is evident from that relation. Accepted? Now you can have a discussion that suppose epsilon is equal to 1, then what will be m from that relation of m and epsilon? If epsilon is equal to 1, m is greater than 1, so the integer value is 2. It means that from term number 2 onwards in the sequence, if you take any two values in the sequence, the difference between them is at most epsilon. That means at most 1. Let me say, if you take epsilon is equal to 1 by 2, then what will be m choice? Three, because m is greater than 1 by epsilon, so m must be greater than 2, so you should take m is equal to 3. It means that from term number 3 onwards, all the values in the sequence are becoming equal with a gap of 1 by 2. If you take epsilon is equal to 1 by 4, then it will be 5. I think that from this relation, it makes sense that you have built a relation between epsilon and term number. So it is a Cauchy sequence. Because for a given epsilon, you are able to specify a term number such that from this term number onwards, all the values are in the sequence are becoming equal. Okay? Any questions, please? Right. So let us take one more problem on this. Can I erase? Fine. So you take the sequence that -1 whole power n by n. You take that sequence. So if you write Sn, it is -1 whole power n by n. If you write Sm, it is -1 whole power m by m. Accepted? Right. Now you assume that n is greater than m and you calculate the difference as usual. So you consider mod Sn minus Sm. So the value is nothing but modulus of -1 whole power n by n minus -1 whole power m by m. Since we can separate the modulus, so this is less than or equal to modulus of since modulus gives a positive value, you can say that this is equal to 1 by n plus 1 by m. Accepted? Right. All we want to do is first we make a possibility for epsilon, and based on that we should specify a term number. Since you know that n is greater than m, so 1 by n is less than 1 by m. So here you can say that this is less than 1 by m and it is already 1 by m. So the value is 2 by m. You can take modulus of a minus b less than or equal to mod a plus mod b. Can we do like that? It is just a value, right? The same thing I have applied there. Fine. So at this position you choose epsilon. So choose epsilon greater than 0 such that 2 by m is less than epsilon. Now this must give the relation for us between m and epsilon. So what happens here? This implies m by 2 is greater than epsilon. Am I correct? 2 by m is less than epsilon. Right? So this implies m is greater than 2 epsilon. Say. So this will give a relation with regard to m and epsilon. So if you take epsilon is equal to 1, m will be 3. If you take epsilon is equal to another number, m will be different. I have done a mistake that it should be greater than 1 by epsilon, right? By taking the reciprocal. Am I correct now? You should interchange the terms. Right. So if epsilon is equal to 1, it must be greater than 2. If epsilon is equal to 1 by 2, m must be greater than 4. Likewise, we are doing. So for each epsilon, you are able to specify a term number here. Hence, the given sequence is nothing but a Cauchy sequence. Please understand one thing, that in the whole sequence, if you are able to specify two term numbers such that the difference between them is greater than epsilon, it is not a Cauchy sequence. That is enough. One counterpart example is enough to prove that it is not a Cauchy sequence. Since such case won't exist here, it is a Cauchy sequence. Okay. I think it gives a rough idea over that how to prove it is a Cauchy sequence. So let us take one more on having a Cauchy sequence problem. Then I will take the problems which are not Cauchy sequences. Fine. Yes, because choose epsilon greater than 0. Actually, if you talk of the real life situation, epsilon is nothing but an error. Suppose if you are conducting an experiment, how much error you are going to allow for that experiment? That is nothing but epsilon. If you feel that you are conducting an experiment and taken the readings and you have a tabulated data, you feel that it is a sequence of values. Now what happens if you allowed an error epsilon? So in the set of tabulated values, from this value onwards, all the values are becoming equal with an error gap of epsilon. That is what we are physically saying. So initially, you should have a chance for epsilon. How much epsilon I am going to allow? It varies from a physical situation. That's why every time I am choosing epsilon in a different manner. So choosing epsilon is our choice. And for each epsilon, you should specify a term number. That's the reason. I think that clarifies the doubt. So don't feel that epsilon is something different. So let me say, if you talk of distances, so from a particular area, 0.5 kilometers distance is allowed. So what will be the choice of epsilon in this case? 0.5 kilometer. That's it. It varies from a situation. Okay. So take the thing that you have a sequence 1 by 2 power n. And can you say that it is convergent? Yes or no? Is it a convergent one or not? If so, how? Any inputs from anyone? If it is convergent, how it is convergent? You cannot go for that much test. You can have a very simple result. We have done a problem on this. We have a lengthy discussion about that problem. Can you recollect that? The concept of the sequence R power n? Where -1 less than or less than or equal to 1, we have solved a problem. Yes. So in that we have proved that the R power n is convergent in this case. In other words, it is just like the geometric progression, right? If you talk of that. So it is convergent. We know that it is a convergent sequence, right? So now I am proving it is a Cauchy sequence. So if you take Sn, it is 1 by 2 power n. If you write Sm, it is 1 by 2 power m. And obviously, n is greater than m. Now you consider the difference between them. Now how to evaluate the simplification part here? So one thing is that since n is greater than n, 2 power n is greater than 2 power m. So 1 by 2 power n is less than 1 by 2 power m. So the value in the modulus is negative. So if you remove the modulus, it will come as since you are subtracting a small value from big value, always it is less than 1 by 2 power m. Now at this part, you choose epsilon. So choose epsilon greater than 0 such that 1 by 2 power m is less than epsilon. Now we are going to build a relation between m and epsilon. So how we are doing? So from this we have 2 power m is greater than 1 by epsilon. Applying logarithm on both sides, m log 2 is greater than log of 1 by epsilon, and m is greater than log of 1 by epsilon by log 2. So you should take a term number like that. M must be greater than log of 1 by epsilon by log 2. Okay? Is that clear? It is just doing the simplification over the modulus and specifying a relation between term number and the epsilon. That is the total thing you are doing actually. Okay, right? So that it is a Cauchy sequence. Any questions, please? To anyone? Now let us take some problems which are not Cauchy sequences. So if you have noted this, you please tell. I will go for the other one. So if you take the case of -1 whole power n, the sequence, it is oscillatory sequence, right? -1, 1, -1, 1. Please understand how the term number will be negative. We are not finding a term value, we are finding a term number. If I write S10, it means that I am writing the 10th term of the sequence. You cannot find a -10th term, it is not practically possible, right? Yeah. You should distinguish between the things that if I say that S10 is equal to -4, the 10th term of the sequence is -4. That is the actual meaning here. So if I have written Sn, I am taking the nth term of the sequence. If I have written, let me say, S100, S200. If I have written like this, it means that I am taking the 100 term in the sequence and 200 term in the sequence. I am calculating the difference between the two values. See, m should be always a positive number, right? So please understand, if you take epsilon is equal to 1 by 2, you have a logarithm there, right? I have taken log of 1 by epsilon. If it is epsilon is equal to 1 by 2, it will be log of 2, right? Then it will be positive. Then m is greater than 1. That's why the expression come in the sense that m is greater than log of 1 by epsilon by log 2. So if you take epsilon is equal to 1, it is log 1, 0. So obviously what happens? Right. The first term onwards, all the values will tending to that number. Yeah. So let us go with this one. You know that it is an oscillatory sequence. If you write the sequence values, it is coming like this. Please understand that you can take any two term numbers. You can take a term number here. You can take a term number here. At anywhere you can take the term number. Fine. And you are calculating the difference between the two values. That is the actual intention of Cauchy sequence. So how I am proving that it is not a Cauchy sequence? We have so many definitions. Generally, for proving that it is not a Cauchy sequence, we use this technique. So for proving that the given sequence is not a Cauchy sequence, we always use this definition. So if you have taken SP, it is nothing but minus 1 whole power P. If you have written SQ, it is minus 1 whole power Q. Accepted? And obviously I have taken that P comma Q are greater than or equal to M. Any term number you can take. Now I am calculating SP minus SQ. Since P comma Q are any two positive values, I can take any values, right? I can take M, I can take 2M, I can take 3M, anything I can take, right? But the thing is, P and Q must be bigger than M, isn't it? Are you getting the logic? P comma Q greater than or equal to M. Please understand that if I have taken M is equal to 100, you can take P and Q starting from 100 any two term numbers. So you can take P is equal to 1000 and you can take Q is equal to 10,000. That doesn't matter. Okay. You are just taking two term numbers which are bigger than M. And you are calculating the difference of those values in the sequence. Does it make sense? So if I have taken P is equal to 1000, I can take Q is equal to 1500. That is also acceptable. I am just taking two term values there. P and Q must be greater than or equal to M. You can take P and Q as one number is 100, another number is 101. You can take the successive values, term numbers, or you can take any two term numbers in the sequence, starting from M onwards. So if you take P is equal to 2M, another one is equal to 2M minus 2. Please understand 2M minus 2, right? That is also acceptable. So let us do that. So you are saying that P is equal to 2M and Q is equal to 2M minus 2, right? So let us do like that. So this is equal to, so SP means minus 1 whole power P, SQ means minus 1 whole power Q. As we have given that P means minus 1 whole power 2M minus 1 whole power 2M minus 2. Am I correct here? Yeah. So this gives what? Can you tell? So minus 1 whole power 2M, that will be 1. Accepted? And this will be, is it positive or negative? 1. So we are getting it as 0, right? Yeah. So you can have any two possibilities. Since you have taken the even numbers, since the sequence is minus 1 whole power something, as in when you take the powers are even, always you should get 0. The result is always less than epsilon. That is practically possible. So what happens if you take an even number and an odd number? Let us check. That we can do, right? So let us do that. So you take that one number, you can take one even number, one odd number. So I will write like this. This is 2m and this is 2m plus 1. One is odd number and one is even number. So if we calculate what happens, this will be minus 1 whole power 2m plus 1 and this will be minus 1 whole power 2m. So the result is minus 1 minus 1. This is equal to 2, right? Accepted? Now at this point you listen carefully. If I say that it is a Cauchy sequence for each epsilon greater than 0, I can find term number. Such that the difference is less than epsilon. If it is not a Cauchy sequence, it means that if I can find two term values for a given epsilon such that the difference is greater than epsilon, it is not a Cauchy sequence. I just mentioned that if I have listed the values in the sequence, you pick up this term, you pick up this term, you calculate the difference of the term values, the function values, it is greater than epsilon, so it is not a Cauchy sequence. That is the idea. So what happens if I take epsilon is equal to 1 by 2, here I have calculated and I have taken two term numbers. One term number is 2m, another term number is 2m plus 1. I have calculated the difference between the sequence values. It is equal to 2, so it is greater than epsilon. Accepted? So the condition is violated here, so it is not a Cauchy sequence. So you can take that it is 1 by 2, 1 by 4, 1 by 8, 1 by 6. So whatever the epsilon you choose, I am able to find two term numbers in the sequence such that the difference between the function values is bigger than epsilon. So it is not a Cauchy sequence. I think it gives the clarity over how it is not a Cauchy sequence, right? Yeah. Let us take two more problems on this. Shall we? Yeah. Can I erase this? I am going to erase this. Fine. Now you take the sequence n square. So if you list out the terms of the sequence, it is nothing but 1, 4, 9, 16, so on. So is it convergent or divergent? Can you find the lower bound and upper bound of this sequence? Is it possible? No, because it is divergent. We know that. Now I am proving that it is not a Cauchy sequence. How to? So you take that P comma Q greater than or equal to M. You consider SP minus SQ or SQ minus SP, whatever it is. So from this time you can say that it is P square minus Q square. It is of the form A square minus B square. You can say that A plus B into A minus B. Now what happens? P is a term number, Q is a term number which are bigger than M. Let us use the same technique as usual earlier. So you take that P is equal to 2m plus 1, Q is equal to 2m. One is even number, one is odd number. So you apply the same thing here. If you substitute the values here, what it could be? The value can you compute? 4m plus 1, right? Actually, it is minus of 4m plus 1 in the modulus, so you are getting it as 4m plus 1. Am I correct? Right. So, here I am saying that it is always greater than 1, yes or no? Because m is positive, right? The starting term number is 1, so you can take m as 1. So it is always greater than 1. So you can take epsilon is equal to 1 by 3, 1 by 4, 1 by 5, 1, anything. You have identified that there are two term numbers. One term number is 2m plus 1, another term number is 2m. So if you calculate the two things, it is becoming greater than epsilon, so it is not a Cauchy sequence. Is that clear? Right. So let us go for two problems on this Cauchy sequence, which are given the examination point of view. They were important. Let us go with this. Can I? So let us take the sequence as this is my sequence. So the claim of the problem is it is not convergent. So this is the problem given to you. I have a sequence Sn. The nth term of the sequence is defined like this, and I am asking you to prove that the sequence is not convergent. This is the task given to you. Now, to prove this problem, however, you have the technique of other, what you call it as sandwich theorem, etc., etc. I am not at all using the technique. Since the task is it is not convergent, so I am saying that if possible, let Sn is convergent. So I am proving it in the opposite manner, the contradictory way. So what happens? I start the procedure. At a moment, I will get a contradiction. So since we know that every convergent sequence is a Cauchy sequence, this implies that Sn is a Cauchy sequence. Now you are calculating the or applying the Cauchy sequence definition here. So you take that n greater than m. So you consider Sn minus Sm. So please understand that if I write Sm, it means that 1 plus 1 by 2 plus so on plus 1 by m. If I write Sn, it means that 1 plus 1 by 2 plus so on plus 1 by m plus 1 by m plus 1 plus so on plus 1 by n. Because the sequence is defined in the sum model. Did you get? Yes or no? Now I am calculating the difference between these two, Sn minus Sm. So what will be? I am subtracting this value minus this value. The result is nothing but 1 by m plus 1 plus 1 by m plus 2 plus so on plus 1 by m plus n. Sorry, 1 by n. So since you have observed that the values in the sequence are positive, the inside value of the modulus is a positive. Will you agree? So that same value will be taken as it is by removing the modulus. So it is 1 by m plus 1 plus 1 by m plus 2 plus so on plus 1 by n. Now please understand one thing, that m is a term number. N is a term number. I can choose n bigger than any value of m. So I am taking that here n is equal to 2m. So for n is equal to 2m, mod Sn minus Sm, if you consider, it is accepted. Because I can take n as any term number bigger than m. So I have taken 2m. Why I have taken 2m, I will tell you later. The technique inside it. Why I am taking 2m. Fine. Any questions at this point? So, at this moment, I can say that it is greater than 1 by m. Accepted? I can say like this also, 2m, so on 2m. Please understand, you are picking up n based on m. N must be a term number which is bigger than m. That was the case here. So if I say that m is 100, you can take n more than 100, 101, 102, 103, anything you take. I am taking n as 200. Okay. So I am saying like this, it is greater than 1 by 2m, 1 by 2m, 1 by 2m. That's why your point is right there. So because we have m plus 1 is less than 2m, m plus 2 is less than 2m, and so on, less than or equal to, you can say 2m is less than or equal to m. So by taking the reciprocal, this one will hold. Accepted? Now, how many terms are there here? Total? M. Why? Because this is m, this is n. So I have taken n is equal to 2m. The gap between them is nothing but m. Right? Yeah. So I am adding 1 by 2m m times. So this is equal to, accepted? Okay. So what you have obtained here, you have concluded the result that modulus of Sn minus Sm is greater than 1 by 2. This is your conclusion for n is equal to 2m. Everyone agrees with this point? Now I am one more time taking the definition of Cauchy sequence. If I say that Sn is a Cauchy sequence, for epsilon, I can find m such that so this is true for every epsilon. So if I say that epsilon is equal to 1 by 2, I can find a term number such that modulus of Sn minus Sm is less than 1 by 2 for all n greater than m. Now, in the problem, our aim is to prove that it is not convergent. In a opposite way, we have taken that it is a convergent sequence. So, from the definition, we can say that it is a Cauchy sequence. So, if I take epsilon is equal to 1 by 2, since it is a Cauchy sequence, I can find a term number m such that modulus of Sn minus Sm is less than 1 by 2 for all n greater than m. It means that you can take n as any term number. If you calculate the difference between these two, it must be less than 1 by 2. That is mandatory because you have taken that Sn is a Cauchy sequence. But what is happening here? For epsilon is equal to 1 by 2, you have identified a term number 2m, which is bigger than m. The difference between these two is becoming more than epsilon. So it is not a Cauchy sequence, which is a contradiction. So why this contradiction is arrived? In the beginning, you have taken that it is convergent. So it must not be convergent. That was the conclusion. Okay? Does it make sense? So the thing is, if you take epsilon is equal to 1 by 2, you can take n is equal to 2m. So if you take epsilon is equal to 1 by 3, you take n is equal to something different, so that you will get bigger than epsilon, right? Accepted. So the usual notation is, generally we take epsilon is equal to 1 by 2 and we take n is equal to 2m, so that simplification will come like this. The value will become greater than epsilon. That was the usual technique we follow. So let us take one more problem with a similar approach so that you will get full clarity over Cauchy sequence. Can I? Fine. Have you noted this? So this is the other problem. I have defined we can also say it is less than 1 by m plus 1 by m plus so on plus 1 by m, which is less than. And how do we know that it's convergent or divergent before knowing it from starting? Please understand, in the very question, the task is clear. So I agree with your argument. If the question is given that verify the convergence, this technique is not useful because you don't know whether it is convergent or divergent. But the objective is clearly mentioned in the question part. Prove that it is not convergent. Since I don't have a straightaway technique, I am using the technique of Cauchy sequence. So how I am using? By assuming in the opposite way, say it is convergent. Then you start the procedure. So you are saying that if a sequence is given to you, without knowing its convergence or divergence, how I am straight away saying that it is a Cauchy sequence, it is not a Cauchy sequence, isn't it? Am I somewhat related to your words? Say, is my logic similar to your words or not? Right. So I am saying that the strategy what you are learning is one of the methodologies for a given problem. It is up to you to choose the methodology in the exam point of view. So the technique of Cauchy sequence usually applied from the task perspective. So usually if a question is given that prove that it is convergent, then apply Cauchy sequence technique. Prove that it is not convergent, then apply Cauchy sequence technique. Otherwise, we should go with the previous methodologies because you don't know the nature of the sequence. Okay? I think it clarifies your doubt. Right. you take the sequence as 1 plus 1 by 3 plus 1 by 5 plus so on plus 1 by 2n minus 1. So here I am taking the sum of the odd numbers, right? So if I take n is equal to 9, what will be S9? 1 plus 1 by 3 plus 1 by 5 plus 1 by 7? No. N is 9. Let us take a small number. Let us take n is equal to 4. It will be somewhat useful, right? So 1 plus 1 by 3 plus 1 by 5 plus 1 by 7. Accepted? So if you take n is equal to 9, it will be up to 17. 1 plus 1 by 3 plus 1 by 5 plus so on plus 1 by 17. So that is the type of the sequence that is given there. Now, the question itself given that prove that it is not convergent. Right away it is given that it is not convergent. So now what happens? We use the same technique. If possible, let it is convergent. So it becomes a Cauchy sequence. So we do the same thing as it is. You consider Sn minus Sm, where is n is greater than m. So I will write the words. So Sm is equal to 1 plus 1 by 3 plus so on plus 1 by 2m minus 1. If I write Sn, it is 1 plus 1 by 3 plus so on plus 1 by 2m minus 1 plus 1 by 2m plus 1 plus so on plus 1 by 2n minus 1. Because I am taking the odd values in the denominator. Accepted all? Now, if you consider the difference between the two, modulus of Sn minus Sm is equal to modulus of 1 by 2m plus 1, 1 by 2m plus 3, so on plus 1 by 2n minus 1. Since the values are positive, you can straight away write like this. Please check that. So here will I say that so as usual, if you take n is equal to 2m, so the last value will be 4m minus 1. So I am taking it is greater than 1 by 4m, 1 by 4m, 1 by 4m. So what happens? You are taking m times. So you have proved that so if you take that epsilon is equal to 1 by 4, you have identified a term number 2m such that difference between them is greater than 1 by 4. It is a contradiction. Therefore, it is not a convergent sequence. So this is the whole part about the sequences chapter. So in a nutshell, let me give the ideology. With regard to UPSC point of view, sequences has less priority for the preparation. So for UPSC point of view, we give the priority for monotone convergence theorem technique and problems based on that. That is one. Secondly, for some problems, we prefer the technique of Cauchy's theorem on limits. The average tends to the same limit. The geometric mean tends to the same limit. So usually priority to these problems are given for sequences chapter with regard to UPSC. So the concept of sandwich theorem and the concept of Cauchy sequence has less priority, right? You should understand that, because the whole approach for sequences chapter is nothing but 4 methods. One is the definition, which we rarely use. Second, Moore-Town convergence theorem. Third, standard results. And fourth, Cauchy sequence. These are the 4 models for the sequences chapter. If a sequence is convergent, if the question is asked to you, you are approaching one of the 4 approaches. Fine. Is it clear? So here I want to conclude this chapter. I am going to start a new topic, that is infinite series. May I? Fine. I can assure you that infinite series will be somewhat interesting compared to sequences. You love this chapter because for UPSC point of view, it has more importance, infinite series. And please specify if you have a boredom with regard to reanalysis. Are you getting any boredom for it? Thank you. So just a moment. Forget what you have learned in sequences completely now. Right? Forget about the whole thing, what you have learned. Now we are starting infinite series. So the concept of infinite series is very simple, that suppose I have a sequence of real numbers. Now I am going to add all the values. And I just want to know, is it finite or infinite? That is my only intention here. So if you talk of a physical case, let me say, today I have earned 100 rupees. Tomorrow I have 150. Next day 110 rupees. Next day 200 rupees, so on. So I am going to sum up all these values. Please understand, this is happening infinite times. So is it a finite value or infinite? That was the question. So if you talk of that, if you want a small story with regard to that, I will give a story to get a small interest. Can I? So earlier there is a king and a scholar approached the king. So the scholar impressed the king and king has given what you want and asked. Then the scholar replied that you just take the chessboard. It is just like a 8x8 matrix. In the chessboard, in the first box you take 1 rupee. In the next box you take 2, then 4, then 8 and so on. Then in the last box, the 64th box, whatever the amount is there, that much number of rupees you give to me. I think you have known this story. I hope so. Okay. Have you known this story? So just take a small story. So the scholar approached the king, asked that you take the chess game. It contains 64 boxes. So in the first box you take 1 rupee, second box 2 rupees, third box 4 rupees. So what you are doing, every time you are making the double than the previous. So in the last box, how many rupees you obtain, that much number of rupees you please give to me. That is my gift. Okay. Now what happens? If you observe this, this is 2 power 0, 2 power 1, 2 square, 2 cube, so on. The last one will be 2 power 64. Sorry, 2 power 63. Right? So, is it a finite number or infinite number? You can check. You can check for calci. It will give a huge number. So finally, the king obeyed that he is defeated. So please forgive me. The scholar went out. This is the whole idea. So what happens if you take for the infinite terms? So if this sum is finite, then the sum of the infinite terms is also finite. So it is just the case that you take 1 plus 1 by 4 plus 1 by 9 plus 1 by 16 plus so on. I am asking you that if I add these infinite numbers, the whole sum, is it finite or infinite? That is I am asking. So what happens? You check the pattern of the sequences. It is of the form 1 by 2 power n. Since it is convergent, for it is a geometric progression. For the geometric progression, sum of the infinite series, we have a formula a by 1 minus r. So by applying the formula, you can say that this is the value of the sum. Am I correct here? It is just like the case. So the whole idea of infinite series is, I have a sequence with me. I am summing all the terms in the sequence, the values in the sequence. I am finding that whether it is a finite sum or not. That is what I am doing actually. So if sum of the infinite values is finite, we say that the series is convergent. It is 1 by n square, sorry, it is 1 by n square, sorry. It is convergent, right? Yeah. Where I am? Yeah. So if you take the sum of the infinite values, if the sum is finite, then we say that then it will be wrong. Then we say that it is convergent. So if the sum is not finite, then we say that it is divergent. So the whole concept of infinite series is, you will have given a sequence of real numbers. Obviously, the values are positive usually, and you are calculating the infinite sum. Summation n is equal to 1 to infinity un. And you are simply checking that whether this infinite sum is finite or not. That is the only thing left with you. That's all. Nothing else is there. Okay. So for checking that this infinite sum is finite or not, that is convergent or not, you have a set of conditions. We call them as tests. So for the whole chapter, around you have 10 tests, like comparison test. Again, you have a ratio test, nth root test, Rabi's test, etc., etc. So around you have 10 tests. So on observing the given sequence pattern, we are applying one or more tests, and straight away by checking the conditions of the tests, we say that the series is convergent or divergent. That is the whole idea of this chapter. Fine. You please check that. Any questions to anyone? Yeah. So if the definition is clear for you, I will give the results, the basic results for you. So I will write the definition one more time. So if you have a sequence of real numbers, we are saying that we are verifying summation n is equal to 1 to infinity un is convergent or divergent. That is what we are doing. And this summation n is equal to 1 to infinity, you are calling it as the infinite series. Fine. So I will list out the conditions one after the other. May I? What are the test conditions which are there? Just hold for a moment. So in this session, I want to give the test conditions for you. In the upcoming session, let us go with the problems, because if I have taken all at once, that will give a confusion for you. Yeah. So first one is comparison test. So if I write the whole condition, you will get it out. I will write the synopsis. See, I have two series. Sigma un and sigma vn of non-negative terms. And I am saying that un less than or equal to k into vn. If sigma vn is convergent, then sigma un is convergent. That is one. The second one is if I can say the value is coming like this. If un is greater than or equal to k into vn, then so please take a note of this. In this chapter, I am just giving the results first, then we go with the problems. The idea of comparison test is very simple. Just understand that I have a series with me. To verify that it is convergent or divergent, I have to compare this series with another series. That is why we are calling it as the comparison test. So how we are comparing? If you know that there is another series which is bigger than this. If the big series is convergent, the small series is also convergent. Okay? So to say that a series is convergent, we should know a series which is bigger than this and which is convergent. Fine. Is the concept clear? Right. if you want to say that a series is divergent, again, this is my given series. You should find a series which is smaller than this, smaller than the given series. If small series is divergent, it is also divergent. In a simple nutshell, for convergence, we need a bigger series. For divergence, we need a smaller series. That is one line idea. Okay? Is the part clear for everyone? Right. I will read the other test. The other one is limit comparison test. Suppose you have two series of positive terms. Right? Such that please take a note of that. This is the statement of limit comparison test. Please take a note of it. So here I have taken two series. I am calculating the limit of un by vn. So un means nth term of the first sequence, vn means nth term of the second sequence, and the limit is existed. If the limit value is not equal to 0, then both the series have same nature. It means both will converge or both will diverge. And what happens if the limit is equal to 0, then if the denominator is convergent, then only numerator convergent. Okay? That was the statement of limit comparison test. Please check. Is the definition clear? Yes or no? Right. Can I erase this? Fine. The next one is nth root test. Again, it is given by Kachis. The statement is sigma un is a series of positive terms. Then if sigma vn is divergent, you cannot decide the nature. Sometimes it is convergent, sometimes it is divergent. That's why the case of convergence only given there. Okay. So for Kachi's nth root test, Please take a note of this. So the nth root test says that if you have a series of positive terms, so for the nth term, you take nth root, apply the limit. If the limit is less than 1, it is convergent. If the limit is greater than 1, it is divergent. And limit equal to 1, this test is not useful. You cannot say whether it is convergent or divergent. Okay? Is it fine? Right. So another one is P-series test. The series is convergent if P is greater than 1. P-series test says that if you have taken a series of the form summation 1 by n power p, that equal to 1 by 1 power p plus 1 by 2 power p plus 1 by 3 power p plus so on, then that sum is a finite value if p is greater than 1. So please take a note of this. So can I give the other? Okay. I promise you that the problems in infinite series will be interesting for you. Apart from these test results, the problems will be interesting for you. Again, we have ratio test here. We also call it as D'Alembert's test. Another name for it is the same condition we take here. So it says that you have a series of positive terms. Such that limit n tends to infinity, un plus 1 by un is equal to L. Then if L less than 1, sigma un is convergent. If L is greater than 1, it is divergent. If L is equal to 1, the test fails. Please take a note of it. So it is again the same ratio test. Here the condition is little modified. So if you have a series of positive terms, you calculate the limit. If the limit is less than 1, it is convergent. If it is greater than 1, it is divergent. If limit value equal to 1, the test fails. And I just give one more test. It is called Rabi's test. Again, you take sigma un, there is series of positive terms. Here you are verifying the condition as limit n tends to infinity n into 1 minus un plus 1 by un. This is equal to L. The condition says that if L greater than 1, convergent, L less than 1, divergent, L equal to 1, test fails. This is the case of Rabi's test. So usually we use Rabi's test when the ratio test fails. So here I have given total 4 tests for you: limit comparison, nth root test, ratio test, and Rabi's test. So for the next session, that is on Saturday, we are discussing on these things. Yes, exactly. For ratio test, rabbit test is the opposite. It is the opposite. That's why I mentioned that as and when this test fails, we apply this. Please understand, in the whole chapter we have 10 conditions, 10 testing conditions. That is for the whole chapter, that's all. On looking a series, immediately we apply one of the tests. I will give you what test to be applied for this series. If the condition is satisfied, it is done. Immediately you will say that it is convergent or divergent, that's all, you are done. That is the whole idea of this chapter. It will be just a problematic type. Theory is very less. Okay. So on Saturday, please read the conditions of the tests. -1 whole power n by x power n by n is uniformly convergent. Please understand, -1 uniformly convergent is different case. It's a different issue. We are not talking for this. Convergent, uniform convergent is totally different. Right? There is a separate chapter we discuss at that moment. After having this, we will discuss over the uniform convergence. Okay? Right. So once you know the convergence, then we discuss uniform convergence. The pattern is like this. We have the 3 modules. One is convergence. Another one is absolute convergence. And then the other one is uniform convergence. These are 3 different issues. So we will discuss one after the other later. Because for uniform convergence, there are different tests are there for which we are going to apply there. Okay, that's it. So here we conclude our session. We will meet on Saturday. So I request everyone to please read the tests. That is very useful for you. If you don't know these conditions before the class will be somewhat not useful. Please understand. So once you know the conditions, solving problems will be very interesting for you. Otherwise, you will get very boredom over the session, I will say. And I request your feedback that are you able to follow this kind of things, or it is very hard for you to follow? Is this better, or it is you are feeling it is somewhat vague? You are doing something different, unable to cope up with the situation like that. Because based on your feedback, I am going to take the topics. Or if you are not interested, you are getting disinterested, I will change my topic. So is that elaboration in the explanation is enough for you? Or you need a little more? Thank you. Yeah. So I will give you for each chapter, with regard to the examination point of view, what you need to concentrate. And if possible, I will take majority of the problems taken from the previous year questions and I will solve it in the class itself. I want to give less burden for you with regard to previous year questions, so that you will have a good idea. Fine. So anything else from your side to me? So for your thing, I will simply say that if you have you started reading any standard textbook, or you didn't? Right. Then you go like this. Since we have done with the linear programming, are you able to solve the previous year questions as per the class sessions are concerned? Then I will give the assignment based on the previous year questions. Tomorrow you will get a posting on it. You solve the questions. As and when you have a doubt, you post the questions. I will clarify by taking a doubt clarifying session. And secondly, for real analysis, so I will give after infinite series or while taking the classes for infinite series, the set of problems for you. A problem set I will give you. So after having the class session, simultaneously you solve these questions, you will get command over the subject. That is enough. Then you can take care of the previous year questions if you are interested, because I will cover majority of the previous year questions in the class itself. So at the end, you can go for standard textbook, and I can say you can concentrate 2 hours per day for the initial preparation. Once you have the confidence, you can minimize that. 2 hours is requested. What are the topic you choose initially? Later, 1 hour reading is sufficient for you. If you have already a textbook with you, simultaneously you can follow that. Otherwise, first concentrate only on the class concepts, then go with the standard textbook. Because it is not possible to cover whole exercise, whole textbook in the class itself. I will take the majority which are important in the examination point of view, and the whole concepts in a nutshell. Okay? Thank you. So that's all for today's session.